Today we are going to understand JWT from beginner to professional level in a practical way. JWT is commonly used to secure APIs and recognize a user on every request after login. Here's the problem. You log in once, but after that you make many requests, like loading profile, fetching orders, or saving settings. So how does the server recognize you on every request without asking you to log in again? JWT is one common solution. Client means the app that sends requests, like a browser or mobile app. Server means the backend that receives requests and returns responses. An API request is a message to get data or perform an action. Now, what is a token? A token is a piece of text used as proof. After login, the server gives the client a token, and the client sends it back on future requests. Now, what is JWT? JWT means JSON Web Token. It is a compact token the client sends to the server to prove identity and permissions. Now, let us understand what a JWT contains. A JWT has three parts: header, payload, and signature. These three parts are separated by dots. Now explain each part. The header is like a label. It describes the token type and the signing method used to protect the token. The payload is the content part. It contains claims. Claims are fields like user identifier, expiry time, and sometimes roles or permissions. The signature is the protection part. It is created by the server to prevent tampering. Now, an important concept. The header and payload are encoded for transport. This makes the token compact and safe to send in web requests. But encoding is not encryption. Encoding means the content can still be read if someone has the token, so never put secrets in the payload. Now, signing. Signing means the server creates the signature using a signing algorithm and a key. Verification means the server checks that signature when it receives the token. Here is a simple tampering example. Imagine the payload says the user ID is 123. The server signs the token and gives it to the client. If someone changes the user ID to 456, the signature will no longer match. When the server verifies the token, it detects the change and rejects the token. This is the main reason signatures exist. Now explain signing algorithm briefly and clearly. A signing algorithm is the method used to create and verify the signature. Two common signing approaches exist. One approach uses a shared secret. This is commonly referred to as HS-256. The same secret is used to sign and to verify. Use this when your system is simple, like one API server or a small number of trusted services that can safely share one secret. The other approach uses a private key to sign and a public key to verify. This is commonly referred to as RS-256. Use this when many services need to verify tokens or when you want verification to be shared widely without giving other services the power to create tokens. That is all you need to remember. Signing protects the token from being modified. The algorithm choice mainly changes how keys are managed across services. Let us start with a real-world example of how JWT works. A user opens an app and logs in by sending their username and password to the server through a secure connection. The server checks the credentials. If they are correct, the server confirms the user identity. After that, the server creates a JWT token. This token includes basic information like the user ID and an expiry time. The server also signs the token so it cannot be changed by anyone else. Now, the client stores this token for future use. Depending on the app, it can be stored in a cookie, local storage, or only in memory. From this point onward, every time the user calls an API, the client sends the token along with the request. When the server receives the request, it verifies the token's signature and checks whether the token is expired. If everything is valid, the server sends back the protected data. If the token is expired or modified, the server rejects the request, and the user must log in again. This same pattern repeats for every request after login. Now, server-side prerequisites. The server must have a way to authenticate users during login. The server must have logic to create tokens with correct claims and expiry time. The server must have a signing key configured. The server must have verification logic on protected routes to verify signatures and validate claims. Now, client-side prerequisites. The client must have a login flow to obtain the token. The client must store the token safely. The client must attach the token to protected requests. Now, storage choices, explained simply. Some systems store tokens in HTTP-only cookie. HTTP-only means JavaScript in the browser cannot read the cookie. This can reduce token theft if a malicious script ever runs in the page. Some systems store tokens in memory. This is safer than long-term storage, but will be lost on page refresh. Some systems store tokens in local storage. This is easy but riskier because a malicious script can read local storage. Now, transport rules. Always send tokens only over HTTPS. HTTPS protects tokens from being read on the network. Now, what the server does when it receives a protected request. First, it extracts the token. Second, it verifies the signature using the expected algorithm and key. Third, it checks time rules like expiry. Fourth, it reads the user identity and permissions from claims. Fifth, it authorizes the request. If the token is missing, invalid, or expired, it rejects the request as an authentication failure. If the token is valid but permission is missing, it rejects the request as an authorization failure. Now, access tokens and refresh tokens. Access token is used on normal API calls and is usually short-lived. Refresh token is used to get a new access token. When the access token expires, the client uses the refresh token to request a new access token. Refresh tokens should be stored more securely and should be revocable. Now, a very important advanced concept: signing versus encryption. Signing makes the token tamper-proof, but not secret. It protects integrity, not confidentiality. If you must keep claims confidential, you need encryption. This is where JWE comes in. JWE means the payload is encrypted, so it becomes unreadable without a decryption key. Use this when the token contains sensitive information that must not be visible to anyone who gets the token. In many systems, the safest approach is still to keep tokens minimal and avoid putting sensitive personal data into them. Now, final summary. JWT is a compact token the client sends on every request after login. It has a header, a payload, and a signature. The server signs the token so it can detect tampering. The server verifies signature and claims on every protected request. Signing does not hide data, so do not store secrets in the payload. If you need confidentiality, use encryption such as JWE. That is JWT from beginner to practical pro level.